Welcome to AINN, your official AI news network. Today we're diving into three of the most important AI model releases of 2025, each one a breakthrough in reasoning, math, and code generation. From DeepSeek's jaw-dropping 671 billion parameter theorem prover to Xiaomi's ultra-efficient MiMo 7B and Microsoft's surprisingly powerful 5-4 reasoning models, this is the new frontier of specialized artificial intelligence. These aren't general-purpose chatbots. They are sharp tools built to master specific domains, from formal theorem proving to coding to step-by-step problem solving. And together, they reveal a shift in the AI landscape, from bigger to better, from generic to expert, from centralized to accessible. Let's begin with the most ambitious model in the lineup. DeepSeek Prover V2 is a 671 billion parameter AI model engineered to perform one task at a superhuman level: formal theorem proving. This model doesn't just generate answers. It crafts step-by-step mathematical proofs that can be formally verified within the Lean 4 proof assistant. In other words, it doesn't approximate logic, it rigorously proves it. Built on DeepSeek's advanced V3 architecture and using a mixture of experts' MOE design, Prover V2 operates with a high level of parameter efficiency. Through FP8 quantization, DeepSeek compressed the model's size to about 650 gigabytes, enormous by most standards, yet remarkably compact for its scale. The full version features 61 transformer layers and a hidden size of over 7,000 dimensions, with an ultra-long contents capacity extending to 163,000 tokens. That allows it to analyze deeply nested mathematical statements, legal arguments, or layered logical constructs far beyond the capabilities of prior systems. But size is only one part of the equation. What truly sets Prover V2 apart is performance. On the Mini F2F benchmark, a rigorous test of formal math problem solving, it scored an astounding 88.9% pass rate. On Putnam Bench, which simulates advanced competition-level math scenarios, it solved 49 out of 658 problems. These are not typical textbook exercises. They're the kinds of questions that challenge elite students and professionals. It also tackled the new Prover Bench dataset, including AIM problems from recent years, solving 6 out of 15 under strict proof constraints. This level of performance suggests more than just rote memorization or pattern matching. It hints at a model capable of genuine symbolic reasoning. That's why its implications are so broad. In education, Prover V2 could serve as a tutor, not just giving answers, but offering formal derivations with precise logic steps. In software engineering and cybersecurity, it could verify that critical systems meet safety and correctness requirements. In academia, it could assist in generating or verifying new mathematical theorems. What makes this even more significant is accessibility. Despite its size, DeepSeek released Prover V2 under the MIT open source license. The full model weights, some 650 gigabytes, are freely available for download on platforms like Hugging Face. Alongside it, they released a smaller 7B parameter variant for users with limited hardware, broadening the reach of formal theorem proving AI. But this open release hasn't come without pushback. While many applaud the transparency and research benefits, others warn of serious risks. With no usage guardrails, anyone can repurpose or fine-tune the model for unintended or even harmful applications. Unlike closed systems like ChatGPT, there are no built-in safeguards or monitoring. Some experts have compared this moment to a kind of Sputnik shock, a sudden leap in OpenAI capability that could accelerate both innovation and misuse globally. Critics argue that releasing frontier models like Prover V2 without restrictions invites security vulnerabilities, misinformation risks, or unintended amplification in adjacent technologies. Proponents, however, emphasize the need for scientific freedom. They argue that controlled access stifles research, and that openness allows the global community to test, refine, and understand what these models are truly capable of. Ultimately, DeepSeek Prover V2 represents both a technological triumph and a test case for the ethics of OpenAI. Its release marks a turning point, a signal that advanced formal reasoning models are no longer confined to labs. They're now part of the global research ecosystem. What happens next depends not just on what the model can do, but on how we choose to use it. It's a classic tension, innovation versus control, and it's not going away anytime soon. Next, we turn to Xiaomi, a company best known for smartphones, now making a name for itself in advanced AI. With the release of MiMo 7B, Xiaomi has launched a model that redefines what a compact AI system can accomplish. At just 7 billion parameters, MiMo 7B might seem modest in a world dominated by mega models. But Xiaomi didn't just build a smaller model. They engineered it to be smarter and more focused. MiMo 7B was pre-trained on an enormous 25 trillion tokens, heavily curated to include high-quality data for mathematical reasoning and code generation. This focus gave the model strong foundations in logic, problem-solving, and algorithmic thinking. The architecture supports multi-token prediction, which helps MiMo generate more coherent sequences and reason more fluidly. But the real innovation came after pre-training. Xiaomi applied reinforcement learning techniques to sharpen its capabilities. Using a dataset of 130,000 curated math and coding problems, they trained the model to learn from both success and failure. A carefully tuned reward system guided it to produce accurate and logically consistent outputs. This post-training effort produced several model variants. MIMO 7B Base, the foundation model with strong reasoning ability. MIMO 7B SFT, fine-tuned for following instructions. MIMO 7B RL Zeno, trained directly with reinforcement learning from the base. MIMO 7B RL, the most advanced variant, combining supervised fine-tuning and RL for best-in-class performance. The numbers are impressive. MIMO 7B RL scored 68.2 on the AINN 2025 test, a competition-grade math exam. It achieved 95.8% on the math benchmark and 57.8% on live code bench v5, a tough test for real-world coding. In all cases, it either matched or outperformed much larger models, including OpenAI's O1 Mini and Alibaba's 32B Quinn model. Another standout feature is MIMO 7B's 32,768 token context window. That allows it to process extremely long code bases, multi-part math questions, or extended logical reasoning chains, comparable to GPT-4's extended context mode. But where MIMO truly shines is in accessibility. Despite its sophistication, MIMO can run locally on a single high VRAM workstation. There's no need for enterprise-scale compute power. This makes it an ideal choice for researchers, startups, educators, and even hobbyist developers looking to work with cutting-edge reasoning tools. Imagine a high school or university student fine-tuning MIMO for use in a classroom tutoring app, or a small software firm integrating MIMO into its QA pipeline to help catch bugs and edge cases in algorithmic code. These are no longer far-off possibilities. They're entirely feasible with MIMO's open-source release under the MIT license. Moreover, the availability of multiple specialized versions makes MIMO a flexible tool. Whether you need instruction following, step-by-step solutions, or raw code generation, there's a MIMO model ready to go. MIMO also highlights a growing trend in AI. Capability is no longer just about scale. With the right training methods and architecture, a 7B model can rival or exceed 30B plus models in domain-specific performance. Xiaomi's strategic approach, combining massive, well-targeted training data with task-specific reinforcement learning, delivers not just a smaller model, but a more useful one. It's a reminder that in AI, size matters less than precision, focus, and usability. In an era where developers want tools that are fast, lean, and effective, MIMO 7B is exactly that. A practical, high-performance solution that opens the door to sophisticated AI development without the need for massive infrastructure. Xiaomi's message is clear: intelligent design can outmatch brute force. In a world chasing ever larger models, MIMO 7B stands out as a triumph of efficiency and specialization. Microsoft's 5.4 Reasoning and 5.4 Reasoning Plus are part of a growing movement towards smaller, smarter, and more focused AI models. With just 14 billion parameters, these models sit well below the size of today's frontier systems. But don't let the number fool you. They are built for performance. 5.4 models were developed using a refined two-phase training process. First came supervised fine-tuning using curated reasoning demonstrations, detailed, step-by-step examples drawn from math, science, and logic problems. These demonstrations weren't randomly selected. They were carefully chosen to emphasize reasoning, structure, and clarity. Microsoft even used advanced models, like OpenAI's O3 Mini, as teacher models to generate part of this training data, helping 5.4 learn how to think before it speaks. Next came reinforcement learning. This stage rewarded the model not just for correct answers, but for demonstrating clear, logical chains of thought. 5.4 Reasoning Plus, the more advanced version, takes about 1.5 times more tokens at inference, but that added verbosity translates into greater accuracy on challenging queries. In practical terms, it's the difference between an AI that guesses and one that genuinely works through a problem. And it shows in the results. On the AINN 2025 math test, 5.4 Reasoning Plus didn't just perform well, it outscored DeepSeek's 70B distilled model. It came close to matching the full 671B DeepSeek R1 model on several reasoning tasks, despite having just a fraction of the parameter count. That kind of efficiency is unheard of in earlier generation models. 5.4 supports a long context window of up to 32,000 tokens, allowing it to ingest complex documents, long programming logic, or multi-part academic questions. This makes it ideal for research use, scientific modeling, or real-world enterprise settings where information comes in dense, structured formats. The model also includes a built-in reasoning trace. This means it shows its work, breaking down problems into structured thought before arriving at a final answer. Developers and researchers can audit these steps, which is invaluable for debugging, safety reviews, and gaining trust in mission-critical applications. 5.4 models are fully open source, licensed under MIT, and available both on Hugging Face and through Azure's AI endpoints. This lowers the barrier to experimentation. A developer with a single high-end GPU can download, fine-tune, and deploy Phi 4 locally without the cost or complexity of multi-GPU infrastructure. Use cases are broad, from automated tutors in STEM education to coding assistants that explain their logic, to decision support systems in fields like finance or healthcare. Anywhere that step-by-step clarity matters, Phi 4 becomes a powerful tool. But more than a tool, Phi 4 reflects a philosophy. It's Microsoft's answer to the question, what if AI didn't just speak fluently, but reasoned clearly? What if we prioritized transparency, reproducibility, and safety without compromising performance? In an industry still dominated by the chase for scale, Phi 4 is a reminder that elegance and precision often win the race. It proves that strategic training can allow a smaller model to compete with and sometimes outperform giants. As other companies push toward the next 100 billion parameter model, Microsoft is staking a different claim, that reasoning is not just about raw power, but design. Phi 4 is their flag in the ground, and it's drawing attention for all the right reasons. It's a model built not just to work, but to work visibly and verifiably. So what does this all mean? DeepSeek, Xiaomi, and Microsoft are showing us where the industry is heading. Toward specialization, models that master tasks, not just mimic conversation. Toward accessibility, AI that can run locally, efficiently, affordably. And toward openness, with all the opportunity and risk that entails. These models aren't just technical milestones, they're strategic signals. They reflect a growing consensus. The future of AI isn't about who builds the biggest model. It's about who builds the right one for the right job. Stay curious, stay informed, and we'll see you on AINN News.